View Learning Objectives. Learning Objectives. After completing this module, you will be able to describe an atom. Compare the structure of an atom proposed by Thompson, Rutherford, and Bohr. Predict different structures of an atom. An atom consists of a nucleus that is composed of protons and neutrons. The nucleus is surrounded by electrons. Protons are positively charged particles, and neutrons have no charge. Thus, the nucleus of an atom is positively charged. Overall, an atom is electrically neutral because it has the same number of electrons as protons. Scientists' understanding of atoms continues to evolve. One of the first atomic models was proposed by J.J. Thompson in 1904. Ernest Rutherford proposed an alternative model in 1911. Just 2 years later, Niels Bohr refined the model. Let's find out how these models differ. Move to the highlighted area using your controller. The shiny gray solid is magnesium. Let's explore 3 atomic models of a magnesium atom. Select the highlighted label to view the corresponding model of a magnesium atom. J.J. Thompson proposed a model of the atom in 1904. His model suggested that an atom consists of a sphere of positive charge, with negatively charged electrons embedded inside it. Select the highlighted label to view the corresponding model of a magnesium atom. In 1911, on the basis of the alpha particle scattering experiment, Rutherford proposed a nuclear model of the atom. According to Rutherford's model, an atom consists of a small, dense, positively charged nucleus located at the center of the atom, while negatively charged electrons revolve in empty space around the nucleus. The electrons in Rutherford's model are revolving around the nucleus in well-defined orbits. Scientists have since learned that the orbital revolution of the electron is not expected to be stable or well-defined. This is the drawback of Rutherford's atomic model. Select the highlighted label to view the corresponding model of a magnesium atom. In 1913, Niels Bohr described a new arrangement of electrons in an atom to explain its stability. According to Bohr's atomic model, the electrons move rapidly around the nucleus in fixed circular paths called energy levels, denoted by the numbers 1, 2, 3, and so on. A magnesium atom has 12 electrons. You can see that the number of electrons in the K, L, and M shells are 2, 8, and 2 respectively. You have completed this activity. Select OK to return to the menu and continue to the next activity. Assess your knowledge. Follow the instructions to perform the assessment and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. There are 2 substances on the table. The petri dish contains carbon and the gas cylinder contains helium. Select the petri dish containing carbon to view models of a carbon atom. Move to the highlighted area using your controller. Select the atomic model proposed by Bohr. Right! Question 1. Bohr's atomic model of carbon has shells. A, 4. B, 2. Correct! The Bohr atomic model of carbon has 2 shells, K and L. Move to the highlighted area using your controller. Select the cylinder containing helium to view models of a helium atom. Move to the highlighted area using your controller. Select the atomic model for helium proposed by Rutherford. Right! Question 2. According to the Rutherford atomic model, the charge on the nucleus is A. Positive, B. Negative. Right! Move to the highlighted area using your controller. Select the atomic model for helium proposed by Thompson. Right! Thompson's atomic model suggests that an atom consists of a sphere of positive charge, with negatively charged electrons embedded inside it. You have completed the assessment. Here is your score. You scored well, and you have completed the module. Select OK to return to the menu where you can exit.